Now, with that knowledge, we've only just set some attribute. That is not an attribute that is recognized by bullet. What we need to do is build our own thing. We need to say, hey, are you a constraint traveling from one piece within your cluster to another piece within your cluster? If you are really strong. If you are a constraint traveling from one piece of one cluster to a different kind of cluster, then you're weak. That will encourage these bonds to break while keeping these bonds together. So back here when we were naming things and giving constraints, this is actually what we need to change. So I'm gonna try to explain this as I go along, but it's a little complicated. So you might need to look up some of the reference for this. I will make it bigger though. What we need to do is, and I'll start at the middle even, we need to find out the point number that we're even talking about. This primitive wrangler is going to run on each of the polygon lines. So each of the polygon lines connects 2 points. But it doesn't know about points. The polygons, the primitives only know about vertices. So we say from input 0, which is the incoming geometry stream, and because this is running on every single primitive that there is, aka every line there is, we're going to ask it. This primnum is going to change for every line. So we're going to say from input 0 for the current primitive that we're currently iterating on, get me vertex 0. There's only going to be a vertex 0 and a vertex 1 because each line only connects 2 points. So it'll always be 0 and 1. That will get us the vertex number overall, what they call the linear vertex number in Houdini. There's just a long list of vertices I should say, but that doesn't give us the actual point number. So we need to convert that using this vertex point. Same thing, input 0, and then the vertex that we just got from this is the second argument. So it looks like this. And that overall will be, we'll say 0.0. Does that make sense? I hope so. You might need to look it up to really drive this home, to understand that Houdini has primitives. When they're polygons, those primitives are made up of vertices, and those vertices point to underlying point numbers. So I just duplicated this and just changed, instead of asking for vertices 0, give me vertex 1. And then that is going to get us 0.1. Before we even continue any further, I would say, if I were to look at this, I'm going to select this guy here. So I selected one of these polygon lines, vertices. So I just deleted it. I'm going to move it over here. And from that, I'll say delete non-selected. So there it is. Geometry spreadsheet. I actually turned this online. This only shows selected off. It has a vertex. Every primitive has a vertex 0 and a vertex 1, and they point back to the underlying point numbers in here. So that's what's going on. As we're here, we have a whole bunch of primitives. We have a whole bunch of vertices. In fact, this number on the left is the primitive number. Primitive 30308 is the primitive number. And as you can see, it's 0, 1, 0, 1, 0, 1, 0, 1, because all of these are just lines connecting 2 points. And it shows you here what is the actual point number. These are the points here. Vertices in Houdini are different than points. Vertices are the kind of the bridge between points and primitives. So that is why this looks the way that it does. So again, I'm not going to spend any more time on it than that, but suffice to say, we have just found out 0.0 and 0.1 on either end of that constraint line. So with that knowledge, let's find out what is the actual cluster attribute, because that's where that's stored. The Voronoi noise thing made an integer cluster on each end of that. So I say cluster 0, go get me the from the same thing, from the incoming geometry, get me the cluster attribute at point 0. And then get me the other cluster attribute at the other location, which are these are the 0, and 0.1, of course, are the integers we just had up here, which are the point numbers. So point is a vex function that just says from input 0, find this attribute at this location, at this actual point number location. So now we have them. So now we can actually do what we came here to do, which is, are these clusters the same? Are we within a cluster right now? So is cluster 0 equal to cluster 1? If it is, then let's have our constraint name. Let's have it be something that indicates that we're inside of the cluster, like something like glue inside. And otherwise, if they're not the same, well, then we know that we're between constraints, or we're between clusters rather. So let's say constraint name is glue outside. And that's really it. Actually, that's not it. We still want to say the strength is 1. Now, you're probably wondering, well, didn't you say before that the whole point of this was the inside ones would be stronger than the outside ones? Well, yeah, but we can change that number on the glue constraints in the simulation itself, rather than change it out here in code. So let's just prove to ourselves that this even worked. Let's make a delete SOP. Let's put it here. And we'll say, hey, is your name, I don't know, glue inside? So here we go. Glue inside successfully is make these little bundled up packages of constraints, which are in the right spot. If we were to look back at the our colorization thing here, see, like, here's this beige kind of clustered area here, or this one for that matter, or any of them. Just look at any of them, and then when I go back over here, you'll see it has the corresponding cluster of constraints on the inside, which must mean that doing the other way, these are all the little connections that will connect between those clusters of constraints. Awesome. So that definitely worked. And like I said, we need to go back into the, oops, I always do that. We need to go back into the sim and set up 2 different glue constraints. I'm going to hide the packed geometry. And look, this is broken now, of course, because there is no glue constraint name anymore. So instead, we need glue outside, which this will be glue outside, and it comes back. And the outside ones are going to be the ones that we want to be weak. So I'm just going to put the 0 for now. 0 doesn't mean that it will break immediately. 0 just means that the slightest provocation will break it. So let's copy that. We'll make a glue inside here. And make sure we change the name here to be glue inside. This is the one that we want to be the default, so I'm just going to revert it back to the 10,000. Merge them together so that we can have both in one thing. And let's actually have the inside be a different color, of course. Let's say this is red, green, blue. So now we have the interior ones are green, and the red ones are the ones that are between them. So I'm just going to stay in constraint view mode here for a second, meaning just that this display is off. And we can just test it. A lot of times, really, even in production, like, we'll just keep the pieces off. Like, we don't need to see them. We're usually more concerned with what are the constraints doing, because that's what really will define how it moves. So once again, we have a very fast sim because nothing can collide with anybody else, but we haven't actually forced anything to break apart yet, so that's actually correct. But more to the point, we have them all set up, looking nice, easy to see, and now let's actually break them apart in the next chapter when we talk about forces.